Welcome to the next section of the AP Calc Summer Packet. This video is on section J, and section J is all about how to take inverses of functions. Okay, so the definition of what it means to take an inverse, you should know exactly what that is. I know we talked about it in Algebra 2, you probably did it again in pre-calc. The whole idea is when you think about a function, functions have inputs, and usually we use the variable x to represent that. And functions have outputs, and we use the variable y to represent that. Sometimes we call it f of x. Well, to take an inverse of a function, all you're doing is you're flipping input and output, x and y. So for instance, if we have an equation like this, 4x plus 15y equals 30, and I ask you to find that inverse, all you're doing is you're leaving the 4, the 15, and the 30 exactly where you found them, but you're flipping the x with the y and the y with the x. Okay, technically that's the inverse, but we can do one better than that. We can solve for y. So we'll bring the 15x over to the right side. We'll divide through by 4. And we get y equals negative 15/4 x plus 15 over 2. So we would say that that is the inverse of the given function or the given equation. We can even say, use the notation, f inverse of x equals negative 15/4 x plus 15 over 2. All right, really just that simple. Let's look at another example. So if I give you, we'll put this one in y equals form, the square root of 8 minus 2x cubed. And I ask you to find f inverse. Find the inverse of this function. Okay, so what we do is, to take the inverse, we flip-flop x and y. So now we rewrite the equation as x equals the square root of 8 minus 2y cubed. But we never like equations with x by itself. We want to get this y by itself again. So first thing we do is we undo the square root by squaring both sides. X squared is going to equal 8 minus 2y cubed without the radical. We'll bring the 8 over, so we'll subtract. Then we'll divide through by negative 2. And we get, I don't like negatives in front, so I'm going to rearrange things and say that this is 4 minus 1/2 x equals y cubed. And then to get the y by itself, we take a cube root of both sides. So f inverse of x will be the cube root of 4 minus 1/2 x. Okay? Now, what if I ask you to find domains and ranges of inverses? And there is one problem in the packet where you do that. Remember the whole idea of what I said at the very beginning of this short video. To take an inverse, you flip-flop, I'm giving the answer away. You flip-flop input and output. Remember what your domain and range are defined to be, and we talked about that in the first video of this series. The domain is all of your inputs. The range is all of your outputs. So if we want to get the domain and range of an inverse, we just flip-flop the domain and range of the original function. What was the domain is now the range. What was the range is now the domain. So here's a function. F of x equals x squared plus 3. Without actually finding the equation for the inverse, can we come up with what the domain and range of the inverse of this function is? So what is domain and range of f inverse of x? Well, for starters, let's come up with what the domain and the range of f of x is. All right, well, this is a parabola. It is a parabola that has a vertex at 0, 3, so it's somewhere up here if we do a rough sketch. So my domain, because it's a nice polynomial, is going to be all the reals. So in interval notation, it's the open interval from negative infinity to positive infinity. My range, because we have a vertex at 0, 3, is going to be all the y's from positive 3 inclusive up to positive infinity. So we have the interval from 3 to positive infinity. It is closed at the left end point of 3, but open at the right end point of infinity. Now, to figure out the domain and range of f inverse of x, normally, yes, we would just flip the two sets, but sometimes you've got to be a little careful. The The thing you got to be careful about is the range. You've got to make sure that your range guarantees you that f inverse is also a function. This happens, if you remember, if you really are good with your trig. This happens when we talk about the domain and range of arc sine, arc cosine, the inverse trig functions. Because remember, if we just flip the x and y for something like cosine, we end up getting something that's not a function unless we restrict arc cosine to be just one iteration of the wave, if you will, of the sine curve. We're going to have to do something like that here, because if you think about it, if we take the inverse of x squared plus 3, I'll do a little rough sketch of the graph over here in the corner, we would get something that kind of looks like this. And if you notice, that doesn't pass the vertical line test. That wouldn't be a function. So what we're going to do is we're going to flip-flop the domain and range slightly. We're going to keep the domain the same as the range. We are going to go from 3 to positive infinity. But the range isn't going to be all reals. Okay? And in fact, I kind of actually drew this a little bit off. Really, the function should look more like this. It should be over at positive 3. I'm only going to take half of the graph, and I'm going to say that the range is from 0 to positive infinity. Because if I use the entire real number line, any vertical line that I draw on said graph will fail the vertical line test and we don't have a function. But if I just go for the first quadrant from 0 to positive infinity, then I'm okay. Okay? So just be careful with that if I ask you to do something like this, and I do ask you to do something like this on the packet. I don't know if this will necessarily be an issue that you have to run into, but in general, it's not just as simple as flip-flopping domain and range. You want to make sure that you can flip-flop the domain and range, but make sure that by doing so, you're not forcing yourself to create something that's no longer a function. Okay? With that, thank you for watching, and best of luck as you continue on through the summer assignment.